Okay, these proofs are all about parallel lines and looking at our vocabulary from Unit 1 with parallel lines and transversals. So we have our corresponding alternate interior, alternate exterior, same side interior, same side exterior. And you had that review of what those vocabulary words are in your warm-up today. Couple of things that I want to point out to you in these definitions here before we talk about what the word converse means is, remember, anytime you have corresponding angles, the relationship is that they're congruent. Alternate interiors, congruent. Alternate exteriors, congruent. Same side interiors, supplementary. Remember, they add up to 180. Same side exteriors, supplementary. So before, when we talked about parallel lines and transversals, we said that if the lines are parallel, then those corresponding angles would be congruent. We started with the parallel lines, and then we saw the relationship of congruent or supplementary. Well, today we're going to work with a converse, and converse just means to switch. So today we're saying, okay, if we know those angles are congruent, now we know the lines are parallel, and that's what we're trying to prove, that the lines are parallel based on that converse. So here is an example. We look at our givens and we know we have 3 of them. Okay, so let's go ahead and write given by all 3. All right, another thing that you want to point out to yourself is taking those 2 angles that they gave you. So they talked about angle 3 and angle 7. We can see based on our vocabulary that angle 3 and angle 7 are corresponding angles because they're both on the left of the transversal and below their line. So let's make a note to ourselves that they're corresponding. And based on the definitions on the previous slide, correspondings will be congruent. So those are some things that you're going to see in your proof down here and have to use as you're working along. Okay. So based on the givens, we know x is 30. So looking at the next step, we can see that they are plugging 30 in for all the x's. So if they plug something in, that is substitution. And then they combine those. They'd say 4 times 30 minus 80 and 3 times 30 minus 50. And so if that's just combining stuff, that is called simplifying. It's something that's happening on one side of the equal sign. It's not like you're adding to both sides. It's just happening on one side of the equal sign. That's always simplifying. Now, looking at this step here that I just put a line beside compared to the next step down, we can see that they got rid of their 40s. Well, that is your transitive property. Remember, to have the transitive property, you have to have 3 statements. Step 1 is here, step 2, and that leads us to step 3, because if 3 and 7 both equal 40, we don't need the 40s. We now know that they are congruent or equal to each other. And so that is your transitive property. All right, we looked at on the last lesson, anytime we have the relationship here going from equal to congruent or congruent to equal, no matter which direction it's going, that is always definition of your congruent angles. And now that we know 3 and 7 are congruent, we can look at our picture and say, okay, because they're congruent, we can now say that lines L and M are parallel because of the converse of corresponding angles. So using your vocabulary and knowing whether they're congruent or supplementary will help you decide which converse you're going to use to prove the lines parallel. So let's look at the next one. We start with our givens, and it looks like we have kind of the same situation to start with. So 3 givens, let's write given on the first 3 lines. Okay. We go over here to our picture and say, okay, 3 and 5. Let's point that out to ourselves. 3 and 5, what kind are they? Well, they're on the same side of the transversal, and they're both in the interior. So that is same side interior. Based on our definitions at the beginning, same side interiors are supplementary. So that means we're going to be using that somewhere. Okay. Now, looking to this next step here after the givens, we can see that they plugged in the 5 into both expressions, to the 10x plus 8 and the 25x minus 3. So if they plug something in, that is substitution. And then to get the 180, they combined the 58 and the 122. So if they combine those, we know that is simplify. And now that we know that they equal 180, we can now state they're supplementary. Remember we said if they spell out a word, that's a big hint to us. So if we go over here to our definitions, the definition of supplementary angles is sum to 180 degrees. And so we can see that we have that definition there, sum to 180. And so we have our definition of supplementary angles. And now that we know they're supplementary, we can concentrate on this part here that I just highlighted in green. Now we know that the lines are parallel because our same side interior angles are supplementary. So we would be using our converse. Okay, we have one more to talk about, and we are going to go ahead and set up our chart. So we have one given. Let's start with that. Okay, first step is given. Now if we look at our picture here, 1 and 2, it's not one of our 5 vocabulary words. They're not corresponding. They're not both in the interior, both in the exterior, on the same side, alternate sides, or none of that. So we're not going to use those as any of our special ones. So let's keep working through here and see if we can figure out which vocab word this relates to. Now on step 1, they did spell a word out. So if we go to our definition here, we can see if they talk about supplementary angles, sum to 180. So we need to make that statement next. So we could say the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and that's because of the definition of supplementary angles. Okay, so we now know that. Now, we don't know much else from the given. So we look at our picture and go, okay, what else do we know that we don't have to prove? Well, we know that these two right here, 1 and 3, are a linear pair because they're adjacent and they make a straight line. So we can say that next and say angle 1 and angle 3 are a linear pair. Okay, and so we think, okay, well, we spelled something out. Let's look here. Definition of a linear pair forms a straight line. Does that justify the definition? Yes. So we would say the definition of a linear pair. I'm going to abbreviate that. Okay, so what else do we get from a linear pair? Not only do they make a straight line, but they are also supplementary. So if we know they're a linear pair, then we know that they are also supplementary. Okay, now if we go to our definitions here, supplementary says sum to 180. Well, if we go back here, we haven't said that yet. All we know for sure is that we have a linear pair. So I'm going to go down here to my theorems, and I'm going to look at this theorem here. If two angles form a linear pair, then they are supplementary. Well, line, believe it's 3, yeah. Line 3 says that they're a linear pair. Line 4 says they're supplementary, so that justifies that theorem. And we can say that this is a linear pair theorem. Okay, next would be that angle 2 is congruent to angle 3. So let's look here. We know that 1 and 2 are supplementary, and so are 1 and 3. So if 1 and 2 are supplementary and 1 and 3, they both add up to 180 and they're both supplementary to angle 1, then 2 and 3 have to be congruent. And I want you to look at this one in pink. So if two angles are supplementary to the same angle, so they're both supplementary to angle 1, then the angles are congruent. So this would be your congruent supplements theorem. Okay, and so now if we look at angle 2 and 3, they have a special relationship because they are corresponding angles. They are on the same side of the transversal and they're in the same place. So now that we know they're congruent and that they're corresponding, we can now say that lines R and S are parallel because of your converse of corresponding angles. Okay, and those are your proofs